Hey, Samara. Hey, Jennifer. Yeah. Lexi. Justin. Rafika. Hello. Look at that capitalization. So professional. I don't even know how to react to that, Rafika. Taz, good morning. How are you doing, Taz? How's Wolverine TV, buddy? No, Taz, I watched them. I watched the episodes when Miss Parnassi mails them out. It's okay, Taz, keep your head up. Remember, you should never be doing this just to be seen, right? You should just make it because you like doing it and it's fun, right? Oh my god. Oh, bruh. I am, okay. Hi, Esther. Let's start at 5 minutes. So it's 3 minutes so far, 2 more minutes left. Got a short lesson today. I want you just to kind of take it as you will, as a short introduction to light, and we are going to get right in the thick of things next week. Yeah. Thanks, Josephine. Hi, Rosie. Lots of eyes. Hello, Lon. Ooh. Alexi, -1. Hey, John. Hello, Meg. Okay, so we're at 4:30. You got 20 more seconds. Sit tight. Okay, let's get started. So, get ready for a crash course on light. Okay? What did you say? Light? Yeah. Okay. That was just for fun. I actually want to really save electricity, so we're gonna turn that off. So light is a wave, right? How do I know it's a wave? Think about it. Our original definition of a wave, right? Does anyone remember? Does anyone remember the original definition of a wave? It's not some wavy thing that has a crest, or some periodically generated displacement of a medium. No, No, that's not what a wave is, right? Do you guys remember what a wave is? No one? No one in the chat remembers what a wave is? Come on. To quote Alexi, oh, come on, cry face. That is a property of a wave, that it oscillates. It doesn't have to. No, Gallagher, that's a water wave. What about a sound wave? What about a wave that travels in the stream? Thank you, Lara. +1, +10. Wow. Yes, it is the transfer of energy, right? It's moving energy from one point to another point. All right, Justin, you get +5. All right, you're second. Okay. Right. So using this definition of a wave, which is the most like general definition of a wave, okay. What evidence do I have of light being wave? What about light? What evidence do I have of light facilitating the transfer of energy? Good morning, Vicky. Put it in the chat, right? Write it down in your notes, type it up in the chat. What evidence do I have of light transferring energy? Remember, energy has a lot of forms. It has like gravitational potential, chemical potential, spring potential, kinetic energy, heat, electric energy, right? Light produces heat. Light comes out of our flashlights and on the wall. So it's transferring, right? So let's take a look at the case of a flashlight, right? In that case, it's taking electric potential energy, it decreases it, and then when it hits the wall, the heat increases. So there I have a transfer of energy, right? At one point the energy is decreasing, and the other point it's increasing, right? Same thing with the sun. The sun loses chemical potential energy when it undergoes like nuclear and chemical reactions, and then trillions of miles away on Earth, we see the Earth heat up. So the sun is giving the Earth energy. It's transferring energy from the sun to the Earth, and that's all the evidence I ever need to say that light is also a wave, right? Cool. So now that I know that light is a wave, whoa, okay, there are a lot of cool things I can do, right? Now that I know the light is a wave, I know it has wavelength, it has frequency, it has period, it has amplitude, it has everything else that is associated with a wave, and most importantly, it follows this equation, right? V equals lambda f, all right? But the really cool thing about light, all right, get this, everyone, is that the reason we differentiate light waves from mechanical waves is light does not require a medium. It is the only wave that can travel a vacuum. Sound waves can't travel through a vacuum, right? Because they require particles that they need to compress and refract, right, to create walls of compression that hit your ear eventually and blah 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 blah, right? So light is the only wave that doesn't require a medium. The other way to say that is it's the only wave that can travel through a vacuum. Those are two equivalent statements. I hope you see that. Okay. Not only that, okay, the speed of light in a vacuum, right? Right, this is in a vacuum. Not only is it the only wave that can travel in a vacuum, its speed in a vacuum is absurdly high. It is c. It's abbreviated as the letter c, right? And c is equal to 3 times 10 to the 8th meters per second. Whoa, 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 whoa. Whoa, 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 whoa. How crazy is that? Whoa, 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 whoa. 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 Do you know how fast that is? It's super fast, right? And I'm going to give you a worksheet that kind of deals with that, right? So basically, for most light, this equation becomes 3 times 10 to the 8th meters per second equals lambda times frequency, right? Which means what? Light waves with a large wavelength, right, have a low frequency, and light waves with a small wavelength have a high frequency, right? Just based on this relationship, right? Because the product of the two has to equal, 3 times whatever, okay? Okay. Now, for sound waves, do atoms have shadows? Not really. Okay. Okay. For sound, frequency corresponded to what in sound? If I change the frequency of a sound wave, how do I observe that as a human observer? How do I perceive that difference? A change in frequency corresponds to a change in, put it in the chat, please. Put it in the chat. Pitch, right? Yeah, frequency is pitch. And amplitude is what for a sound wave? Hey, we're going fast today. What does amplitude correspond with? Volume, right? Loudness, dynamics, right? All right, let's do that for light. What would frequency correspond to for light? There's many forms of light, right? Color, exactly, color. Or we call this the type of radiation. Okay? What about amplitude? What does that correspond with? Brightness. Yeah, brightness. You guys are getting it. Awesome. Okay? All right. The last thing I'll say before I go, right, because I do want to keep this short, is the frequency, right? So if I have right? So in terms of color, right, if I have high frequency and low frequency, right, that corresponds with changes in my wavelength. In the grand scheme of things, like red has longer wavelengths and lower frequency, and violet has higher frequencies and smaller wavelengths. And the other colors follow in that spectrum: orange, yellow, green, blue, right? Roy G. Biv, right, is like the thing we know. But there are other forms of light, right? So this is just the visible spectrum, okay? Anything beyond this, right, we call infrared light. And anything a higher frequency than the highest violet we can see we call ultraviolet. Now, within the ultraviolet spectrum, we have different forms of radiation like X-rays and gamma rays and stuff. Those are like subsets of UV, but you wouldn't be wrong to call those X-rays UV, right? So like UV is a subset of, I mean, X-rays are a subset of UV, okay? There are many types of infrared rays as well. Microwaves count as one, and radio waves are the most famous ones. Radio waves are really cool because they're, so radio waves are all the way here. Those are like the lowest frequency ever of any wave that's kind of generated. And what makes them really cool is like their wavelengths are like on the order of a magnitude of a meter. Like, so a radio wave's wavelength is around 1 meter. So it's really big, right? A really popular misconception, though, is what radio waves? I thought radio waves were sound waves. How is radio wave a light wave? Okay, so there's two types of waves that you have to talk about when you're talking about radio. One is the actual radio signal, okay? So there is a radio tower, and it transmits a signal that is picked up by your radio. That signal tells the radio hey, can you guys hear me? It says I'm disconnected to the chat. There might be a little internet issue. Can you hear me? Oh no! Now I'm scared. Well, I'm going to keep going as if you can hear me. Hopefully this will be recorded if you can, and you can watch this at a later time, right? So anyways, let me get back to this. So these signals, these are light waves. These travel at 3 times 10 to the 8th meters per second. And this is a form of invisible light, okay? Your radio antenna picks up that, it can detect that light, unlike your eyeball, all right? And coded in that light is the signal to tell the radio what to play. And the radio will emit sound waves in the air. And these sound waves travel at 340 meters per second in the air. It's a completely different thing. Like the radio wave, when we talk about radio waves, it's not what you hear, it's the signal from the radio tower to the radio that travels at the speed of light, okay? So that's what a radio wave is. I have no idea why the chat function is disabled, but that's it. Expect a worksheet either today or tomorrow. It'll be due Monday morning, all right? And it's just gonna basically walk you through the fundamentals and the basics of light and so on and so forth, okay? Sorry again for the second consecutive day of hashtag technical difficulties. Hopefully these will stop someday, okay? Have a great day, and I'll see you for open office hours tomorrow. Bye.